What's up guys, Matt Voke, callsign Jerry, with the first bite-sized AI compilation video. I packaged the last 9 episodes that I made into one so that it's more easily consumed in one sitting to become that AI ready workforce. So please leave me comments, please like and subscribe for more bite-sized AI. This video will cover artificial intelligence, machine learning, supervised, unsupervised, and reinforcement learning, bias from humans and implications on AI, data, big data, and the 5 V's of data, neural networks, and then DeepFakes and attacking these AI. And what better way to start than, what is artificial intelligence? Artificial intelligence surrounds us. It's everywhere. It's sexy, it's smart, it's funny, it's very powerful. It infuses everything we touch, interact with, and watch. AI makes great movies. It makes great marketing, great products, great experiences. If you want to just think of how powerful Netflix and Amazon are. But what is artificial intelligence? This is very simple and also severely complex. Artificial intelligence at its most basic is the ability of an agent to perform at a superhuman level. So, an unnatural agent, usually meaning a computer, is able to perform tasks traditionally ceded to that of a human. Another definition of artificial intelligence attributes the cognitive functions that humans associate with a human mind, such as learning and reasoning, but not required. An unnatural agent needs to be able to learn and adapt to its environment on par or better than a human to be deemed an artificial intelligence by today's standards. Artificial intelligence uses algorithms, or a set of instructions that sense its environment and then either make a decision or perform an action. The problem and the joy with artificial intelligence is that what is considered intelligent constantly changes. The goalposts keep getting pushed back. We keep needing more and more to be deemed intelligent. As machines become increasingly intelligent, tasks that were once considered requisites for human intelligence have changed. Previously, tasks such as image recognition, human speech, superiority in advanced games, art even, have all been conquered by artificial intelligence. This is one reason that many deem the actual arrival of true artificial intelligence as the singularity, because we just simply can't see beyond it. If you haven't read Ray Kurzweil's The Singularity is Near, I would definitely suggest picking it up. It's a little bit dated, but some of the charts and figures that it has, as well as basic explanations, are pretty awesome. Artificial intelligence, it turns out, is causing us to relook at what we consider human. What is reasoning, knowledge, planning, learning, language, perception, creativity, and so much more. What about ethics? Artificial general intelligence proves to be the holy grail of artificial intelligence because of its ability to bridge narrow, specific domains of application and generalize learning and applicability. The field of AI was founded with specific ideas of what it meant to be intelligent, but we continually evaluate these, even what it even means to be human. Welcome to the rabbit hole, baby. This is artificial intelligence. This is insane. I assume no responsibility for your late nights spent researching, your missed meals, your holistic changes to your perceptions of reality. What does it mean to be intelligent? What makes biological brains different than silicon brains? What can't machines perform better than humans? By far, the most popular concept tied to artificial intelligence is ML. Most people even say them together, AI, ML. It's hot, it's sexy, but how does it differ from artificial intelligence? What exactly is machine learning? We covered what AI is in the last episode, but if you haven't watched that one yet, click above. I described what AI is and what it can do. Machine learning is one of the subsets of artificial intelligence, but have gotten a lot of attention and momentum the last couple of decades, even though it's existed for much, much longer. Machine learning is artificial intelligence where we let the data train the algorithms. This makes sense, right? We humans learn from data and feedback we've collected over the years. What if we're going to do something new that we've never done before? We either ask somebody about it, we read on it, or watch a YouTube video, right? Machine learning is just like that human trying to do something it's never done before, but the big difference is ML, we can afford a lot of trial and error. Let's say we're running a car dealership. We can use machine learning in a couple different ways to help us out. Here are 5 ways ML can be used to increase sales and mitigate loss. Use case number 1. What cars should we stock on our lot? It would probably be smart to look back at what cars have we sold for high margins in the past with minimal time on our lot, right? Great idea. Well, machine learning could chew through the past decades of car sales data and then recommend cars to stock. Using math and computer science, ML can determine correlations and make recommendations. Wouldn't it be cool if we could extrapolate those correlations into the future? Yup. Use case number 2. How do we get people into our dealership? Well, marketing works, right? Great, let's do that. Let's market to the segment of the population who is actually likely to come in if they see the advertisement, and then likely to spend money at our dealership if they come in. Sites like Facebook don't charge you money to use their platforms because you pay them with your data and the ability for them to market and advertise to you. We can target that upper middle income 42 to 55-year-old male when we're trying to move that red Corvette on our lot. We're able to do this based on piles of data. Are you sensing a theme yet? Data is king. Use case number 3 and 4. Which models do we show the individual? How do we haggle on the price? How likely are they to walk away? Again, each of these is determinable through data. Last one, number 5. This one's huge. How do we provide financing to this guy? Do we finance this guy if he's going to be buying our car? Will he default or will he pay that loan back? Are we all right with taking a little bit of a loss if it gets that car sold? You can quickly see how important machine learning is in just this one example, how pervasive it is, and even some areas where it could improve the seller and the consumer experiences. There's 3 basic types of machine learning: supervised learning, unsupervised learning, and reinforcement learning. I'll cover these individually in the next 3 videos. Definitely subscribe if you're not, so you'll be notified when they come out. The key takeaway is that machine learning is very powerful because it's able to learn from data and train algorithms to be more efficient and effective. The more data you have, theoretically, the more powerful your application of ML can be. There's obviously an upper limit. Well, that's machine learning. Pretty simple, right? Last video we looked at machine learning, which is basically AI that learns from data. This video will look at perhaps the most common way of machine learning, supervised learning. Supervised learning is exactly what it sounds: supervised training of AI. The supervisor helps AI link outputs directly to the data parameters it's trained on. The training data is labeled beforehand with features to help link these inputs and outputs. Here's an example AI trained with supervised learning thanks to Silicon Valley. This AI is trained using hundreds of pictures of hot dogs, thousands of pictures of non-hot dogs. During training, the AI learns the features of what makes a picture a hot dog and excludes things that don't.
Yes! It works! Huzzah!
In supervised learning, the most important and time-consuming aspect is gathering and preparing the data. If there aren't enough pictures, or if the pictures aren't given proper labels or features, the AI is bound to fail, in the same way that students that receive the wrong instruction from their teacher won't do well on a test. Once the data is gathered and cleaned, the data's features or inputs train the model that will provide the correct target variable or output. In the hot dog example, the features are the raw pixels of that picture. The target variable is hot dog or not hot dog.
Pizza. Let's do pizza.
Yeah.
Pizza. Okay. Hey, Zach.
Not hot dog?
Eh?
That's it? It only does hot dogs?
No, and a not hot dog.
This AI tells us the classification of the picture. Classification is pretty simple, and TensorFlow Playground is a real cool site that lets you train AI to classify dots. The features are fed into the AI on the left, and the output is displayed on the screen. Pretty simple, but yet extremely powerful. Try segmenting these orange and blue dots using Excel and equations you learned in high school algebra.
I will look for you. I will find you.
Good luck.
Supervised learning can also teach regressions, like we discussed in What's Machine Learning video, of predicting the price of a car. Given the input features, make, model, color, mileage, we can train an AI to output the predicted sales price. Pretty powerful, right? The basics of supervised learning are pretty simple. We can teach AI by giving it inputs and outputs, and it can figure out how those features are linked in those labels. The strength of supervised learning is in the relatively little computational requirement, if done well, and it's a simple and predictable method of learning. The greatest challenge is the significant upfront cost in terms of that data preparation and labeling. The key, it turns out, is the collection and preparation of that data. Are you sensing a trend here? Data is king. Last video we looked at supervised learning, holding AI's hand and helping it determine correlations in data. What's the next logical training method? Unsupervised learning. If supervised learning trains artificial intelligence with labeled data, unsupervised learning obviously trains that AI without labels. Where supervised learning requires that significant upfront cost in order to label massive amounts of data, unsupervised learning doesn't require as significant of that initial lift. It is possible without hand-holding from humans. The downside is a lack of guidance and typically more significant data and computational requirements to teach those models, with less predictable results. So, what's the use of unsupervised learning if it requires more data and compute? What if we don't know how to label the data? Many times we don't even know what patterns or correlations actually exist. What if we don't want to hamstring our discoveries of insights with human imprinted heuristics, bias, preconceived notions, or what correlations should exist? Well, then you have unsupervised learning, my friend. The most common and perhaps the easiest unsupervised learning method to explain is cluster detection. We can easily demonstrate this on an XY scatter plot, although there can be significantly more dimensions than this 2D example. Here, we can semi-randomly plot dots on an XY scale. Some of you may already be able to see that these dots aren't really random, but you can't really make too much out of it. Unsupervised learning is able to help us by suggesting that we break these dots up into 3 categories or clusters. The AI is able to draw the most efficient cluster around these data for us. Now imagine these dots aren't just blue dots. They're height and weight, they're length and color, they're price and size, any feature you can think of. The key is that we don't even need to know these features. We don't really care. We let the AI solve the problem while we're blind, at least initially. That's pretty powerful. We can potentially solve problems not even knowing what the problems are. Taking this one step further, a couple of years ago, Stanford and Google researchers applied these techniques to unsupervised learning on YouTube, and interesting things happened. They were able to build high-level, class-specific feature detectors from only unlabeled data. In other words, they discovered the features of cats with an AI just watching YouTube. Big whoop, right? Wrong.
Double rainbow all the way across the sky.
The simple fact that it was able to learn these high-level features of both cats and humans from just data tells us a couple things. 1, there's a heck of a lot of pictures of cats on the internet. 2, this was the first time that anybody showed that it was possible to train neurons to select high-level concepts like this without labeled data. They literally just let it go, and it figured out these features on its own. Number 3, AI is pretty dang cool. So, unsupervised learning trains AI from data without labels, while supervised learning requires a significant upfront cost in order to label massive amounts of data. Unsupervised learning does not require this initial lift, but it typically needs more data and compute. Weird. Data is king. Remember to smash the thumbs up, subscribe if you want to hear more of this beautiful voice, and isn't AI fascinating? For crying out loud, it taught itself cats. I'm sorry, I'm thinking about cats again. The last couple of videos we learned how AI learns with supervised learning and unsupervised learning. I don't have any favorite algorithms, but my favorite way of teaching AI is reinforcement learning. Do you remember that one time that humans said there was no way AI was able to do stuff? Well, reinforcement learning is behind many of those breakthroughs, and every day there's less and less that humans maintain dominance in. Near the end of this video, I'll show you some crazy examples of AI dethroning humans in dominant areas. Stick around for about 2 minutes. This stuff is great. Just like reinforcing learning in a dog, interesting behaviors result when you reward good behavior and punish bad behavior. The same training can and is being done with AI in very powerful ways. In reinforcement learning, the artificial intelligence learns in an interactive environment through trial and error, using reinforcement loops from its own actions. The AI agent takes some action in its environment which either improves or degrades its score or chance of winning. That behavior is reinforced or dampened so that it is more or less likely to take that action in the future. While supervised learning and unsupervised learning try to find similarities in data, reinforcement learning teaches an AI to maximize its cumulative reward. The main things needed to train AI using this learning style are an interactive environment, the ability for that AI to sense that environment, a reward function creating feedback, and an AI's ability to act in this environment. All right, enough talk, Jerry. You promised us great AI victory. Why, yes, I did. In 2013, Q Learning learned to play and defeat some of the most classic games like Breakout, Space Invaders, Pong, and Qbert. Yes, I realize that Atari is old, but these are great environments for AI to learn, mainly because there's a score to be optimized. Even if the AI knows nothing about the game, not even the rules, it can just see the pixels on the screen and learn to increase its score. After 2 hours of training, the AI is getting pretty good, right? This is probably my level of play after about 2 hours, right? But wait, now after the AI has about 4 hours of training, this is just after 4 hours, it learns it can maximize its score by digging a hole in the corner of the bricks to keep the ball in the air, just pinging off the bricks. This is incredible. It doesn't even know what a ball or a brick are, but it's able to perform at such a superhuman level. In 2013, this paper used reinforcement learning on 7 games. In 2015, Q Learning could defeat professional gamers at 49 Atari games. Breakout isn't very hard though. Of course AI can beat it. Well, how about Dota 2? How about StarCraft 2? These are the most complex games we have, kids. They require long time horizon planning, large action space. We're talking more options per move than all the stars in the universe, and partially observable environments. These games demonstrate one more strength of reinforcement learning, learning to balance the exploration of uncharted behavior and the exploitation of knowing what works. Click above to watch my in-depth coverage of OpenAI defeating the world champs OG. AI has moved from defeating Atari games to defeating the most complex games humans have in 6 years. Astounding. Click here to watch DeepMind's AlphaStar crushing Team Liquid's TLO and Mana. What is reinforcement learning possible of when we take these lessons of awesomeness in complex simulation environments and we apply them in the real world? Man, I'm glad you asked. Thanks, Johnny. Here's a brief example. The same DeepMind AI that beat Atari, these lessons were applied to Google's data center's intense cooling requirements. Using reinforcement learning, DeepMind was able to, quote, consistently achieve 40% reduction in the amount of energy used for cooling. That is huge. Just think how huge this is in terms of dollars and environmental impact. This is great stuff. How crazy is it that AI can learn from just data, and in a lot of cases is more efficient and faster than humans? Now let's talk the accuracy of that AI and how we get unbiased decisions. Buckle up. The future is bright. I think it goes without saying that humans don't always make the most accurate, informed decisions, right? If you're going to make a prediction, the more information that you know about the event, the better you are able to predict the outcome, right? Pretty simple. But what about the things we think we know about the event but aren't hard facts? Heuristics are cognitive shortcuts that help us survive and thrive as humans. We don't have the time to analyze everything in excruciating detail, so we lump threats, treats, and everything in between in buckets. These buckets help humans process the massive amounts of inbound data at exponentially increased rates. This is a double-edged sword though, and is usually good, but sometimes there are adverse consequences. Sometimes they can be catastrophically wrong because of bias, mistakes in data, and in noise. All right, Jerry, so what? Humans are biased, so what do we do about it? Well, that's one of the greatest strengths of AI. Thanks for bringing it up, Toby. AI trains from data. It doesn't have these embedded cognitive shortcuts or bias. Or does it? Most AI is able to provide objective analysis of reality and facts, but sometimes they are led astray. These AI are either trained by humans, or the humans are the ones aggregating and cleaning the data, correct? Well, as it turns out, these human shepherds may be unknowingly imparting their bias on the unwitting AI. Data is king. We have to make efforts to collect this data. It doesn't just collect, clean, and store itself, right? Surveys have been bit by this significantly in the past. Reference the 2016 election. Now, what if we apply this concept to recidivism, or the chance of inmates reoffending? In determining their eligibility for parole, we have a significantly outsized number of minorities incarcerated today, and we have a large number of minorities that are also thrown back in jail after their initial release. The data is astounding here. Have you heard of confirmation bias? Well, this is another great way AI is strong, or it can be led astray. Confirmation bias is a great polarizer and is even inherent in the scientific method. We start with a hypothesis or something we think is right. We do research, sometimes on Facebook, and we are more likely to believe evidence justifying our hypothesis or rejecting the contrary information. This causes humans to become more steadfast and polarized in their beliefs. AI is trained to serve up material that we will like, share, retweet, and follow. AI is employed in echo chambers and reinforcing boards to amplify our cognitive dissonance or our disconnection from fact-based reality. Wow, holy crap, that's a lot. Why, yes, it is, Penelope. And please don't say crap. So, what are we going to do about it? Thanks for asking, Alice. Step 1 is admitting that you have a problem, right? Be cognizant of bias that you're collecting in the data and training AI. Seek to improve data collection, reduce bias, and reduce noise. Noise is the final variable in prediction, and we need to try to eliminate it. And perhaps the easiest way to do so is to aggregate different models. In the aggregation or grouping, we can improve predictions by almost double sometimes. That, my friends, is why you see these awesomely crazy spaghetti charts when a hurricane is heading your way. Wow, that was quick. Time is up. I feel like we are just getting started and scratching the surface. Please leave me a comment on what I missed. Another bite-sized AI video.
Another one.
The last video we talked about human bias and the potential for data to absorb some of those bias. That begs the question, what is data? What is big data? And what's AI got to do with it? You've heard me say several times that data is king. This is perhaps understating its importance a little bit. Data is what allows the king to rule. It's more like king fuel. That's why Andrew Ng likened data and AI to electricity. Just as electricity transformed almost everything 100 years ago, today I have a hard time thinking of an industry that AI won't transform in the next several years. Go ahead, think of one area or industry that doesn't produce masses of data and won't be improved by AI. Nope, that industry is already being disrupted by AI and automation. You said farming, right? Well, how about this factoid bomb? In the 1930s, 30% of the workforce was employed in agriculture, the farming industry. Today, this percentage is closer to 0.3%, 2 orders of magnitude less. This happened through automation and significant improvements using data to overhaul farming. Iterative improvements with data. Think about the increased productivity those people are creating elsewhere. Now, more than 8 million Americans work in the truck driving transportation industry. What do you think will happen with these drivers when autonomy transforms driving? My point with these examples is that any area that has mass of data can train AI to improve performance and is ripe for disruption. Data powers decision and needs to be thought of as a strategic resource. If you haven't watched my video on data to decision yet, I'll link it above. Data is a strategic resource. We must ethically collect and leverage it. When we look at data in AI, here are the 5 V's, the focal areas that make data both awesome and a challenge. Number 1, volume. Volume refers to large amounts of data being produced. Big data. Last year produced more data than the previous 5,000 years combined. And we need AI to help understand it and inform decisions. Number 2, velocity. Velocity refers to the speed this data is flowing through things like computers, sensors, social media, smartphones. As one example, Google receives more than 6 billion searches every day. Wow! The only way you can process this water hose is with AI. Number 3, variety. We need to be able to work with this structured data that is organized and labeled and the unstructured data that is unorganized and doesn't fit into these clean columns, such as video or raw text. Number 4, veracity. Veracity refers to the uncertainty we have in the data. Data is disordered and dirty. We need to clean it. By aggregating data, we are able to make more informed and less noisy decisions. But more data has the potential to overwhelm and confuse. AI is able to deal with this veracity. Finally, number 5, some data is extremely valuable, whereas some is nearly worthless. Data only has value for its potential use. Pretty simple, right? These 5 V's yield lenses to think about how important data is and how to deal with data. Data is a strategic resource. We need to ethically collect and leverage data to improve our decisions. Oh, you're here for the neural nets. Perfect, me too. But be careful. That's foreshadowing. Watch until the end. Neural nets, or neural networks. Even if you don't think you've ever touched AI, you've heard of the term neural networks.
A CPU is a neural net processor, a learning computer.
What are they? Why do people keep raving about them? Great question, thanks Topanga. A neural network is an AI inspired by the neurons and synapses in the human brain. If humans are intelligent, then if we can just model silicon circuits off the brain, then they can be intelligent too, right? Or perhaps even more intelligent. Neural networks interpret inputs, basically numbers, and then feed those numbers through an intricate and increasingly deep number of neurons that develop a more abstract understanding of that data. Neural networks can help us cluster and classify. They can label novel data. They can recommend solutions. They can even create works of art. They can help us make numerical sense of an otherwise complex, overwhelming, and fast-moving world. Because electricity can travel much faster than a series of neurons can fire, these neural nets may theoretically be more powerful than the human brain someday. By the summation of inputs and weights, these bad boys are able to do some pretty heavy lifting. Neural networks are great at image recognition. Take a look at these pictures. What's going on? This deep neural net was able to recognize a couple of young people playing a game of frisbee. Look at that little white dot. That's crazy that it even knew that that was a frisbee. In the middle picture, it veers a little bit off. Yes, these are hockey players, but they're likely on the same team, so they aren't really fighting over a puck. But this neural net's training led it to believe that. Then, in the far right picture, you can see that it thinks that a little girl in a pink hat is blowing a bubble. I'm not sure that this is a little girl. It thinks it is based on the pink hat, but she/he is definitely not blowing a bubble. These 3 pictures do a good job at expressing the great power and challenges of AI. Today's neural nets aren't just looking at pictures of frisbees. They can diagnose cancer better than the leading oncologists. Wow. How about sound and speech? Yup, they can do that too. Look at this AI that is able to take black and white photos and voila, turn them into color 100 years later. How do we know what colors these things were before? Well, we have thousands of training examples from subject matter experts, of course. How about this AI that is able to generate novel images from simple inspiration? All this AI needs is a muse, and it goes to work creating beautiful images, or even turning day into night. And now, welcome to the main event. In the blue corner, we have the genuine, authentic human. And in the red corner, we have DeepFakes. Stay tuned, ladies and gentlemen, for the next event where these two fight. In the red corner, DeepFakes. Fight! The last video we talked about neural nets, how powerful they are, and some examples of how they can do awesome things. They were able to recognize cancer, drive cars, and create speech from scratch. But there's a challenging dark side to these neural networks because we don't understand exactly what's happening inside of their black box. You also may have heard of deepfakes. This video will talk about both of these challenges, and near the end of the video, I'll flip this negative upside down and show you how we can use these challenges to help us with AI. What if I told you that some of these neural nets are so brittle that one pixel or an imperceptible amount of noise could cause them to fail catastrophically? There have been a couple of papers put out on this, and some don't even need to know anything about the construction of the network they're attacking. Check out these examples. By changing one pixel on this unicorn, the neural network thinks it's a 99% sure it's a frog. By changing one pixel on these 9 images, it's able to trick the neural net into thinking the same picture is anything from an airplane to a cat to a deer to a truck. Crazy. What are the implications here? Well, good question, Alejandro. We can never assume that something works all the time, especially with the black box nature of these neural nets. Although something may be very reliable, there may be some areas where it can fail catastrophically without warning. Redundancy is probably a good idea. As an example, in addition to cameras on Tesla cars, they use radar and ultrasonic sensors to mitigate any visual failures. Secondarily, this means that we need robust testing and evaluations of these neural nets. We need to probe how robust these models are, areas of use that should be avoided, and determine how quickly to identify and control these failures. This is step 1 in building trust. Public and private organizations are working on these methods and standard operating procedures, SOPs, now. And now, for the main event. I promised you deepfakes, and deepfakes I shall deliver. Look at these examples and tell me that some of them don't look utterly believable at lower resolutions.
We're entering an era in which our enemies can make it look like anyone is saying anything at any point in time, even if they would never say those things.
These used to be laughably novel, but these are hugely powerful. The same technology that is used to build deepfakes iteratively trains to improve their believability by detecting areas where it's not believable. So they continue to get better and better with neural nets that create the fakes and neural nets that detect the fakes. That's right, we can use 2 opposing neural nets to try and attack and refute each other in order to improve their performance. Iteratively, these adversarial neural networks can improve each other.
You don't scare me! Work on it! Sir, yes, sir!
And the results they produce? Mind-blowing. This obviously isn't limited to deepfakes. Adversarial neural networks are used in cyber defense, text-to-image translation, automatically adjusting photographs, 3D object generation, and video prediction. If you can think of a back-and-forth cat-and-mouse game, odds are you'll be able to use an adversary to help iteratively train your neural net, especially if you're working with images and video.
Because I am hard, you will not like me. But the more you hate me, the more you will learn.
The beauty is, neural networks can do this at the speed of compute. Set these babies up to train overnight and come back in the morning to a product that's several orders of magnitude more capable and believable. The possibilities here are truly profound. What an interesting time. Hopefully you guys liked this video. I'm putting this content out there to help you become a more AI-ready workforce, but let me know in the comments below what you guys want to see, what I can do better to help express that. Definitely hit the likes and subscribe for more bite-sized AI content. This is Jerry. See ya!